We're going to talk about the solution process. Whenever a solution is formed, you take a solute, like salt or sugar or something like that. You dissolve it into a solvent, like water. Now, when this happens, there are three things that have to take place. You have to break the ionic bonds holding together, or whatever bonds are holding together the solute, like the ionic bonds holding together NaCl, but you also have to break the intermolecular forces, the hydrogen bonds holding together the water molecules. Okay, both of these require energy, so both of these are endothermic. Now, when the NaCl dissociates into water, it forms those Na ions and those chloride ions, and the water molecules will start to surround these guys. Now, notice when they surround them, though, the hydrogen ends of the water molecules are close to the chlorine, while the oxygen ends of the water molecules are close to the sodium. This is because of the polarity of water, and it forms new intermolecular forces. These are ion dipole forces. All right, and the formation of these bonds is going to be exothermic. If you take a combination of the endothermic reaction here and the exothermic reaction here, you have the entire heat of what is called solvation of this substance. So let's go back here. We look back at this again. Alright, so we have to break the attractive forces between both the solute particles and the solvent particles. We have to form new forces, ion dipole attractions, between the water molecules and the ions. This whole process, again, is called solvation. And when you do this process involving water, then it's called hydration. Now, the whole thing, we said, when you break up those bonds, both in the solute and in the solvent, are both endothermic. But when these two react, most of the time this is going to be exothermic. All right. Overall, the overall formation can be either endo or exothermic. It just depends on which one of these guys, this one, or this one, is the largest value. So why do ionic solids like NaCl, why won't they dissolve in nonpolar liquids? All right, you have to have that polarity in order to do this thing right over here, in order to form these bonds right here. If you can't form these bonds, then all you're left with are two endothermic reactions that are really not very likely to happen by themselves. There has to be an attractive force between the ions and the polar liquid. The same reason it's the same sort of reasoning for why polar liquids won't form solution with nonpolar liquids. Again, there's not going to be any types of bonds that are forming between them, so there can be no solvation. There can be no surrounding of the solute by the solvent. If you take a combination of all of those exo and endothermic reactions, you get this thing right here, our enthalpy or heat of solution. Usually uses that symbol right there, delta HSOLN. It can be positive if the overall is endothermic, negative if the overall is exothermic. It can also be called the enthalpy of hydration as well. It doesn't have to just be called enthalpy of solution. The next thermodynamic function we're going to look at in regards to solvation is called entropy. Entropy is kind of interesting. It has to do with the second law of thermodynamics, which states that everything in the universe tends to go towards an increase in entropy. And what entropy is its randomness or disorder. This is why your room always tends to go towards messiness instead of order. If you live in your room, it doesn't automatically become clean. It starts getting messier and messier and messier. This obeys the second law of thermodynamics, that the entire universe is always going towards disorder, towards randomness. things tend to favor disorder, and chemical reactions are no exception. There tend to be increases in entropy if the temperature raises, which makes sense. You heat up a solution or a gas, molecules are going to go faster and faster and faster. And the faster it goes, the more random it is, the more disorder there is. Other things that can increase entropy is if you have a state change going from solid to liquid to gas. A solid is the most ordered, a gas is the least ordered, right? So the least amount of entropy, the most amount of entropy. Anytime you dissolve something, anytime you form a solution, you're going to be getting a lot of entropy. Overall, solutions will most likely form when they have a negative delta H, or they're exothermic, and they have an increase in entropy, or a positive S value. S is a symbol for entropy. We'll talk about that more in a chapter down the road. For positive values of delta H, the increase in entropy is actually causing this to dissolve, even though the whole thing is endothermic. And so if you have an endothermic reaction, it can still happen if you're having a huge increase in entropy. The next thing we're going to look at is definition of spontaneity, and this is the last thing we're looking at. Spontaneous reaction is anything that can occur naturally. One thing that a lot of students will confuse right off the bat is they'll think that means it has to happen fast, but it does not have to happen fast. It just needs to happen naturally. Rusting is a spontaneous reaction. The oxidation of iron is a spontaneous reaction. It doesn't happen fast, but it happens without you really doing anything to it. All right, this is what we call a spontaneous reaction. If we look at number 4, spontaneous reactions tend to favor, just like solution formation, tend to favor increases or raises in enthalpies and increasing entropies. So they tend to favor large exothermic enthalpies. They tend to favor increasing entropies. So when you have disorder increasing and when you have heat being released, that usually indicates you have a spontaneous reaction occurring. Not always, but usually.